So let's now go back to trying to find this gradient function for other curves. Not just straight lines, semicircles, parabolas, but any curve. So the slope of a tangent for anything. Here is random curve, y equals function x. I want to find the slope of the tangent at the point P. Now as I say, best I can do at this stage is estimate using 2 points. I'm going to actually use the point P and another point, Q. So the slope of that green line is going to be my estimate for the slope of the tangent. Now I didn't say it was a good estimate, it's just an estimate. So the question then becomes, well, where could I pick Q to get the best possible estimate? I can put Q anywhere on this curve I like. Where would be the best spot to put it? Well, the answer is as close to P as possible. And just imagine sliding that Q down towards P. And hopefully, as you're imagining it, you're seeing that green line moving closer and closer to the blue line. So its slope, therefore, must be getting closer and closer to the one we're looking for. So we want to put it as close as we possibly can. I just thought I'd magnify that for you there. So we want Q to get as close to P as possible. Well, P will have the coordinates x, and its y value will be whatever function x happens to be. Q, well, I've added some value to x, so I'll call it x plus h. And so the y value will be whatever I get when I substitute x plus h into the function. So I can find the slope of PQ, function x plus h minus function x over h. So there is our slope, there is our estimate. Now we said we wanted it as close to possible. So ideally, we'd like to put it so that the difference between them was 0. Because if there was no difference between them, I would now have it exact. Of course, I can't do that. But what I can do is I can investigate the limit as that approaches 0. And if I can find that limit, I'll get the exact answer. So we now change it. Slope of formula is not just going to be function x plus h minus function x over h. It's going to be the limit as h approaches 0 of that. And that will get us an exact answer. Say, gradient function, it's the derivative, or more correctly, when we're talking about number plane graphs, we say it's the derivative of y with respect to x. How is y changing? How is that height changing as x changes? Symbols we use for it, probably the most common, dy dx. Now, where did the d come from? D is probably, it was originally delta for change, and so it changed from a delta to a d over the years, and I would imagine that's where it's probably come from. That dash notation we saw with the gradient function, so some people do that, so y dash, or actually say f dash x. Here's an interesting one. Here, they just simply say, well, I'm differentiating this particular function, so they write the actual function in with respect to x. So instead of saying y dx, they actually write in what y is. But a derivative, okay, we're using it for curve sketching at this point, but where we'll get to is motion and all sorts of things. Anytime you've got something changing with respect to something else, then calculus can be used. So now, rather than writing the word slope of tangent, I'll write in gradient function. F dash x is equal to that. Now, differentiating this way is what we call differentiating from first principles. Right? Now, you might have heard the expression first principles before. It's used in all sorts of things, but it basically means starting from scratch. Starting from the first idea. And this is the first idea, I guess, is looking at the secant and trying to work out what the slope of it would be. We'll start with the one which we know what the answer is, because of course it's a straight line, and we saw that the gradient function for this will just be 6. So let's do it. Function x is 6x plus 1. Before I write the formula out, I tend to work function x plus h out first, and then I just substitute that in. So function x plus h, everywhere I see an x, replace it with x plus h, so we have 6x plus 6h plus 1. Now I'll put it into our formula. 6x plus 6h plus 1 minus 6x plus 1 all over h. That tidies up to be 6h on h. The h's now cancel, factorise and cancel. Because if I was to sub into that, I'd get that 0 on 0 problem. I'm left with a constant 6. Well, if it's constantly 6, well, it doesn't matter that h is approaching 0. Everywhere it's 6. So the answer to that is 6. Now notice my setting out. Limit as h approaches 0 stays there until I do the substitution. So that should be on every line until you actually substitute it. Well, let's do a parabola then. X squared minus 5x plus 2 at the point 1, negative 2. Now remember, we saw before that it was always going to be 2x. So I'm expecting an answer of, well, what would it be? We're at the point 1, negative 2. We're expecting an answer of 2 for the slope. Once we've got the slope, we've got a point slope formula, we can get the equation of the actual tangent. So there's function x squared minus 5x plus 2. Let's work out function x plus h. Whoa, expand the whole thing out. Does anything there? No, nothing simplifies at all there. So we've just got that expression we're going to substitute in. So here's my formula. Sub in. Now the beautiful thing that should happen here is when we do tidy the top up, the only thing I'm going to be left with should have a factor of h in it, which will then allow me to factorise and cancel. And in this case, it does. There you can see. 2xh plus h squared minus 5h over h. So I'm left with 2x plus h minus 5. 2x minus 5. Oh, I was mistaken. Remember I said we were expecting 2x? I didn't get 2x. Why? Why didn't I get 2x? That's what I was expecting. No, we looked at the parabola before. We said the gradient function was 2x. Why is this not giving me 2x? Anyone got an idea at all? Is that a stretch? Or is that a hand up with an idea?
Maybe like the graph's like wider or like skinnier.
Oh, you're on the right track. It's actually not wider. It's exactly the same concavity as y equals x squared. But it has been shifted, yes. The one we looked at was the very specific quadratic y equals x squared. This one is based on y equals x squared. I mean, we could factorise it, but we've got some sort of shift happening here. So that effectively moves the position of the point that we're looking at, why we get a different slope. So we actually have a formula here of 2x minus 5. Now remember, that's not the slope of the tangent. That's the equation that will allow us to find the slope of the tangent. Sub in the point, it actually turns out to be negative 3 for this one. So negative 3. Point slope formula, and there it is, y equals minus 3x plus 1. Oh, I went there, it's there. Right.